Let's start off in our JProco database and do a query for all records and all fields of the employee table. Select star from employee. We see our 12 records. Now we can also see that Alex and Barry have the same working location. They have a different working location than Lee, but David and Eric also work in the same place as Alex and Barry. They work in location 1. Location 1 is the headquarters. But how do we find out where location 1 is? We have a way to get more information about a location than just its ID. We have a location table that gives you the details of each location. Let's write a select query from the location table. The location is Seattle, Washington, more specifically 111 First Street. By running both of these queries at the same time, we can see that Alex Adams works in location 1, which is Seattle, Washington. Barry Brown also works in location 1, which is Seattle, Washington. Leo Sacco works in location 2, which is on 2nd Avenue in Boston. So this second table is what is known as a lookup table. It contains more detailed information about the location ID as referenced from the employee table. Whether or not you have the book, Figure 3.2 gives us a great example of this. As you can see, Alex Adams has a location ID of 1. By looking in the location table for more detail of that, we can see he gets 111 First Street, Seattle, Washington for his work location. As a matter of fact, this process would be repeated for every employee in the employee table who has a location ID of 1. Now, why do we just store location ID of 1 in the employee table rather than repeatedly storing Seattle, Washington, 111 First Street? This process of normalizing your database into related tables saves a lot of space. It also makes updating the database and database maintenance far easier. For example, let's say you had 1,000 employees in Seattle and you wanted to move to a nearby street address of 545 Pike. Well, all you'd have to do is change that one record in the location table for location ID 1, rather than changing every single record of every employee who works in Seattle. So for the sake of space and maintenance, a database must be normalized. Well, that kind of makes reporting a little more difficult. If you want to see a list of employees and the details of where they work, you've got to run 2 queries and look for the corresponding field in each table, and then put them together. Well, you can actually view all of this information in one query, and that's what you will get to see. Okay, I'm giving myself the maximum amount of room since we're working with 2 tables at once. Let's start off by looking at the employee table. 7 fields, 12 records. Location ID 1 is the most popular. Let's look at the location table. Location ID 1 is Seattle. All the details and all the other locations are listed. Running both of them at once solves a few riddles. We know that Alex Adams works in Seattle, Barry Brown works in Seattle, Lee works in Boston. But what if I wanted the word Seattle and all corresponding locations to appear over here to the right of the employee record? How do we put 2 tables in one from clause? Well, we can do this if we know how these tables relate, and we do. We know they both have a location ID. But to be more specific, these are 2 different fields. This one is the employee.location ID, and this one is the location.location ID field. To properly identify a field, you need to specify the table name, then a dot, and then the field name. Let's put both of these tables in the same from clause, and we're going to separate them with the words inner join. Inner came from equa, which means equal. These 2 tables have something they equate on, and you can relate them to. So we specify that these 2 tables are related, but we haven't been specific on just how they're related to each other in SQL Server. That's where the on clause comes in. We're going to say that the employee table has a location ID field, which corresponds to the location table's location ID field. Run this query and notice the location fields appear to the right of each matching record of a location ID found in the employee table, and you get a complete report in one view. Here's another good example of using an inner join. Looking at the employee table, we've got no idea who makes how much money. How much does Alex Adams make per year or per hour? How much does Barry Brown make? Well, if we have their employee ID, we can look that up in the pay rates table. Select star from pay rates and run just this query. We can see that employee number 1 makes $75,000 per year. Employee number 2 makes $78,000 per year. Run both of these queries at once and you get a sort of report. We have to do a little back and forth looking. How much does Lee make? $45 an hour. How much does Lonning make? Employee 7 is $6,100 a month. Okay, let's put both of these tables in the same from clause. Now let me run both of them again. We need to figure out what they both have in common. What is this field and what is this field? Kind of a trick question. This first field is called the employee.empid field. This second field is called the payrates.empid field. Now here's a rule for doing joins. You put the table names in the from and you put the field names in the on. So let's do that. Let's put both tables in the from, separated by the word inner join. Now we need to name the two fields that they will connect on explicitly. On employee.empid equals payrates.empid. Run it, and we can see the exact pay of each and every employee. Time for Lab 3.1 on inner joins, Skill Check 1. In one query, you want to see the employees and the cities where they work. You know the two tables share a common location ID field. From JProCo, query both tables by joining them on this field. Your field select list should include first name and last name from the employee table, city and state from the location table. When you're done, your screen should resemble the figure you see here. Moving on to Skill Check 2. The grant table has an EMP-ID field. List all of the employees' first and last names next to the grants they have found. Show first name, last name, grant name, and amount fields. When you're done, your screen should resemble the figure you see here. Skill Check 3. Change your database context from the JProCo database to the DB Basics database. The activity table shows the books that have been checked out and the library card number of the patron that checked it out. Join the activity table to the members table to see the books and the member details on who checked it out. When you're done, the result should resemble the figure you see here. Skill Check 4. In the DB Basics database, join the purchase activity and the customer tables, but just show the following fields: date, item, price, and customer name. Your results should contain 11 records and resemble the figure you see here.